Hello everyone. So in today's tutorial, we will be learning about another Python library similar to NumPy and it's used extensively while handling a large amount of data sets, and they are called as Pandas. Pandas usually store the data in tabular format, making it very easy for visualization of the data storage as well as accessing the individual data points when performing statistical analysis or we're trying to analyze the data for something. So Pandas is a go-to tool when it comes to data science related projects. So basically, there are three types of data structures in Pandas, that is series, data frame, and panel. In this tutorial, we will be learning in detail about what is a Pandas series and Pandas data frame, how to manipulate them, how to create them, and how to work with them. So let's begin. First of all, what is a Pandas series? So just imagine a typical spreadsheet. You can call it as, or you can call it as a table, as you can see here. Each individual column is called as a series, that is Pandas series, and a combination or a set of Pandas series is called as a data frame. So usually these column heads are called as labels, and these row elements, that is the first cell of each row, is called as an index. So we can access any row using the index, and we can access any column using these labels or column names as we call it. And so this entire thing is a data frame, and panel is quite similar. It's just a 3D visualization of data frame. So let's try to understand what Pandas is actually capable of. Panda and how this can be more efficient and can work with along with NumPy. So Pandas basically can read a variety of file types, whether it's a CSV file or an Excel file or a JSON file, SQL, HTML, and there are a lot of data formats which Pandas can actually read as well as write into. And apart from that, we can also create new tables, as you can see here, or you can add a column or a series to an existing data frame already. Also, we can merge two data frames and create an entirely new data frame, or we can extract a part of the data frame and create it as a separate data frame again. So it's quite versatile, and it's very easy and very comfortable once you get the hang of this library. So now to begin with, first we have to install the package. So this is similar to the exercise what we did for NumPy. In case if this has already not been installed in your system, all you need to do is just take an Conda prompt and say Conda install pandas. Since in my system it has already been installed, so I am going to skip this step, but in case if it is not installed in your system, please follow this command and then the set of instructions that will follow, and you can easily get it installed. So after having installed, what we need to do is import pandas as pd. Like I said, how we use a short form for NumPy, we are going to use a short form for pandas as well. So I have kept this ready already, so I'm going to click run. So now it has been exported, it has been imported into the notebook. So first let's begin with series. So I will take a variable by name s, and I will say pandas dot series, where s is capital and no space, and I'll just give an empty braces. That's it. So basically what I'm trying to do is create an empty series. So now if you try to print what is s and we try to see, it says it's an empty series and the data type is float 64. Don't worry about the warning, and in future they are just saying that this particular data type will not be available. Now, in case if we want to create series from a different data structure like a list or an array or a dictionary, so it's very easy to create a panda series from an already existing data type. So let's see one by one. Now, first let me create an array using the NumPy package which we learned in the last tutorial. So numpy.array, and I'm just going to create a bunch of dummy elements, and I am going to say S is equal to PD dot capital S series, and I will say data. And if you press this, your series is actually ready and you can visualize it like this. So here, as you can see, this 0, 1, 2 are nothing but the index. In fact, you can access each individual element in this series using this index number. For example, if I take S of 0, it says it is A. Okay, so let me just go back. So here the first element is A, so automatically you will get that. And also we know this command already, but I'm still going to repeat it. If I take type of S, I want to find out what exactly is the data type of the variable S, then it says it is a panda core series. So now in the same way, like we saw here, S was actually ABC, and we had the index starting from 0, 1, 2, and this is by default. Even if you're importing an external file also, the indexing will always be by default starting from 0. In case if you want to give your own set of index, all you need to do is just copying the command right away, and I will include another command which is called as index of, let I'll just start with 10, 11 and 12. Okay, so now if I type S, so automatically you can see the index values have changed. So in case if you want to have a different index number, this is how you can change it. And so this is how you can create a Pandas series using an array. Similarly, we can try to create it using a dictionary as well. So I'm going to take the same kind of elements. So I will take A and I will give it as 0, sorry, and then I will take B and I will give it as 1, and I'll take C and I'll give it as 2. Okay, so this is a dictionary wherein you can access the elements 0, 1, 2 using their labels A, B and C. So now I'm going to convert this dictionary into a series by using the command pd.series of data, and I'm going to type it. Now as you can see, it says A is equal to 0, B is equal to 1 and C is equal to 2. Now, like I said, you can access these individual elements as well using their index position, or in this case, I am going to access that using their label, which is S of B, and it says S of B is 1, and it is correct. So in the same way, we can try to create a data frame. So now we know how to create an array from a list and how to create a Pandas series from an array. Or we can also create a Pandas series from the dictionary, wherein the labels will become the index position of a series. Now let's go to the data frame part, wherein we can create a simple data frame. I will start with a variable df, which in fact stands as a short form for data frame, and be careful with the syntax because in the word data frame, D and F are capital, and I'm just creating an empty data frame. It consists of nothing, and you can see that it's an empty data frame. Now if you want to fill something into this data frame, first let me create a list of numbers like this, and then I'm going to say df is equal to pd dot data frame and of data, and then I'm going to type it, and you can see that the data frame is ready. But in this case, the data frame has only one column. So this is basically the number 1, 2, 3, 4, 5. This is basically a series, and the name of the series is 0. And each element of the series can be accessed by its index position, which starts from 0 and ends at 4. Now, in the same way, I am going to create a different type of data frame this time. So, I'm trying to create a list of people and their ages. So there is a guy by name Sachin and his age is 23, and I'm going to create two more like that. And okay, so now I have created a list of three people and their ages. So now basically this is a list, and I want to convert this to a data frame, and let's see how pandas can actually represent them in a data frame. So I will give it as data, comma, and if you want to change the column names, you can use the command columns as name, sorry, name, comma, age. Okay, and if you give d type as float, it will take it as float, otherwise you can leave it. So for now I will not consider it as a float. I will just type it, and you can see in case if this command was not at all given. So this is how it would look, same as the previous example wherein the column name was taken as 0 by default. But since we know what these column heads mean, so I'm going to go with that. And again, if I take the data type as float, well, and you can see the difference. So it has converted into float, and column names have the same name what we had given. Now, in the same way, we can also create a data frame like the same kind of data set but in a different manner. So I'm going to go with data, and it's a dictionary that I'm trying to create here. So it's called as name, and under the label name, I have a set of people like Tom, Jack, and Steve, Ricky, and Charles. Okay, so now under the label name I have 5 people, and again I'm going to create another label wherein I'm mentioning their age, and you can just type in 32, 34, 18, and 26. Okay. So now we have a dictionary where it consists of names and their ages, and I'm going to create a data frame from this dictionary. So in this case, you don't have to separately mention the name of the columns because the dictionary by default has a label, and that is going to directly go and set at the column name place. Okay. So this is one of the example as to how you can create a data frame using the dictionary. Now, one more thing that we can actually do is that we can in fact merge two dictionaries into a single data frame, and we are going to see a very small example of that. Now I have two dictionaries which I am going to call it as A is 1, comma, B is 2. Okay, and I'm going to create another dictionary wherein A is 4 and B is 6, and just to make things interesting, I am going to add another label here, and I'm going to assign a value of 5 for that. So now I have two dictionaries, and let's see how we can combine this into a data frame. And as you can see, a new data frame has been created, and the first dictionary did not have any value for the label C, and hence it is showing it as NaN, which means not a number. Okay, and for the rest of the labels it is filled automatically. Now, so this is one way of doing or converting a dictionary into a data frame. Now, we can also try to see another way wherein you have a set of series and you're trying to combine them into a data frame. So until now, we learned about how we can create using the dictionary. We learned how to do it using the list. And so now we are going to learn how to combine multiple Pandas series into a single data frame. So again, I'm going to take it as data and start with a dictionary symbol, and I'm going to call it as 1 because this is going to be the label or the what you can call it as the column name. And I'm trying to create a series here. So I have created a panda series, and I will say that these elements of the panda series need to be indexed as A, B, and C. Okay, so in the same way, so upon creating, so basically I've tried to create a panda series under the column name or a column head 1. In the same way, I'm going to create another one under column head 2. Okay, so I'm just gonna change here and I'll write it as 2, and let me give it as 4, 5, and 6. Okay, so having done that, so now we have a dictionary that is ready, which consists of two panda series, and we are going to try to merge it into a single data frame. And let's see if it works out. Yes, it works great. As you can see here, we have created two panda series first. That is, one is a is a separate panda series, and two is another separate panda series, and we have tried to merge them by keeping them as a dictionary. So whenever you use a flower braces, it automatically takes it as a dictionary, and we already know how to convert a dictionary into a data frame. So after having done that, so now we have learned about different ways how you can create a panda series, or you can create a data frame format. So I'm coming to the accessible part of a data frame. So how can I access individual element in a data frame? So now we have a label there. I will call it as df of 1. So you can see 1, 2, and 3. In case if I change it to 2, I can see 4, 5, 6. What if I want to access the first row of the second column? So automatically I'm going to give it like this, and you can see the element is 4. So what I was trying to access is this element, and I've been able to access it. So here I mentioned to the program the column and then its corresponding index number. And also another interesting is that you can just type it as a, I am sorry, oh, this is a string, so it needs to be mentioned like that, and you can get 4 also. So depends upon how you have fed the index and the column names or the labels into the data frame. So this is one way how you can access an element, and or we can make it a little more interesting and remove this thing and access the entire row, but there is a separate command for this, which I will call it as allocate. And sorry, I have to give it as locate and run. Okay. So what exactly are these locate and allocate? So locate actually, whenever you are trying to search the data frame row wise, you can use the command called locate or allocate. Locate stands. You can use locate whenever you know the index name. And in case if you are not sure about the index name, then you give it as df allocate and 1. So automatically it is going to display the second row, that is 2 and 5. So if you want to see the same output as this one, then you have to give it as 0 and then you press run. So automatically it fetches the same thing. So these are the two ways of you can actually locate. For that matter, I can even click 1, sorry, um, just keep it as A. Sorry, this doesn't work as well. Okay, so that is about locate and iLocate option. So now another interesting thing that we are going to learn is how to add a new Panda series to an existing data frame. So now we know that we have a data frame which has 2 columns and 3 rows. So I want to add a third column, which is also called as Pandas series. So now what I'm going to do, df, and 3 is going to be the column name of the new Panda series that is going to get added up here. And I will try to create a new Panda series. I will give a list of numbers in that as 10, 11, and 12, and I will keep the index as it is. Just to avoid typing, I'm going to copy it from here and paste it directly. And now you can see a new addition to an existing data frame. But so this is about adding a new Panda series to the data frame. But how about if you want to remove one of the series or one of the columns in a data frame? It's very simple. Del is a keyword which we use, and I will type it as 1, which means I want Pandas or the program to delete a column whose name is 1. So now you can see the 1 is gone and we have only 2 and 3 left. There is also another command which we can use, which is called as df.pop. So df is basically the name of the data frame. So in this case it is df for me, and I will say just pop out 2. So then it's called. We will have only a single column left. Okay, but I have not saved it in a new variable. So that I will explain why I'm saying this, because now if I want this to be available, you can always save it in a new variable and we can try to display that as well. Okay, so now that won't be necessary. Whenever you're dealing with large data sets, it becomes important. And there is a way how you can merge two data frames. So for that, first let me try to create a new data frame, and I will create a list of numbers 3, 4, and I will give columns as A, comma B. So this is a new data frame that I've created, and I'm going to create a similar data frame which is called as df2, and I will change the numbers to 5, 6, 7, and 8. But I'm going to we can keep it and we can also vary. So we'll just move back and forth and we'll try to understand. So df1 is equal to df1 dot append df2. Okay, so what exactly is this command df1 doing? It is basically trying to merge two data frames. So first what we did, we created two independent data frames, that is df1 and df2, which are the same column names, but it is not necessary. We can have a different column names as well. So after having created two separate data frames, we have tried to merge one with another. So when we say use this command, what we are trying to say is that df1 please append df2. So basically new data frame is going to get merged with the existing data frame, that is df1. So now just for the fun of it, I'm going to change one of the column names as C, and let's see what comes out. As you can see here, in df1 there is no input for C, and in df2 there is no input for column name A. So it's not necessary that the column names need to match. It can still create a new data frame and merge two existing data frames as well. So now another example about how you can drop a particular row, because until now we saw about deleting a Panda series or a column in a data frame. Now we are going to learn about how to drop, which is also the syntax here. I want to drop the first row of the data frame df1, and as you can see, the first row has been dropped. Okay, now coming to the next one, and if you can see here, it has actually dropped two of the rows. That is, if, whichever had the index number as 0, it has dropped both the rows here. Okay. Now, next, what we will try to do is that let us create random numbers, and we will learn about how to iterate in a pandas data frame. So speaking of that, I am going to create a set of random numbers, say pd dot data frame numpy. So this is how we integrate numpy with pandas, and I'm trying to create a set of float numbers, and I'm going to mention that it should be a matrix of size 4 cross 3, and I want the columns to be named as column 1, column 2, column 3. Okay, so now I'm creating a new data frame which consists of random numbers, and in fact every time you run this particular command you are not going to end up with the same kind of numbers because it's entirely purely random. So we have created a set of random numbers here. Now what I would like to do is that I want the program to iterate through each and every element in this data frame. So for that we use a for loop, and for key comma value in df dot iter items. This is the syntax wherein it iterates through every element in the data frame. We want it to print the key and value. So what exactly we're trying to say here is, let me just run this so it's very easy for me to explain. Now when I say for key comma value in df.iter items, key basically stands for the index number and value is the value corresponding to that particular index. So it will actually iterate column wise. So that's why in the first iteration it will go to column 1, and since here in the key index position 0 we have the value of 1.65, it gets printed, then it is minus 2.677, then 0.954, and so on and so forth. So after having completed the first column, then it iterates to the second column and the third column, and this is how the iteration process continues. In the same way, if we want it to iterate row wise and not column wise, we can do the same thing but with a little change, and I'm going to write it as row index so that it is not very confusing. For row index comma row in df dot, instead of iter items we have to use it as iter rows, and we are going to print row index comma row. Typing this is going to take a lot of time, so I'm just copy pasting. So here as you can see, it will go through the first row, then the second row, and then the third row. Here the term row index actually stands for column 1, column 2, column 3, and row basically stands for the value. So basically using the terms like key, value, row, index, row as actually not much of a significance. It is just for our understanding that we are mentioning that this represents the key and this represents the value. But in fact the program doesn't care what is the name that you are giving. Now, so having learned how to create an empty panda series or empty data frame, or create a data frame from series, or create a series from an array or a dictionary or a list and so on, and how to manipulate a data frame as well. Now let us try to understand one of the interesting applications of pandas actually, that is to read a file externally. I will go with pd read excel, and using the command R actually helps us in fetching the location. Sometimes what happens, you have the input file which you would like to load into the program in a different location than the one in which your Jupyter notebook is actually running. So in that case, we need this command called as R and then followed by quotes. But in case if your file is already in the same folder as your Jupyter notebook, then you just have to directly mention the name of the file. So in my case, it's not in the same location, so I'm going to copy the location, and also I'm going to copy the file name so that I don't make any mistakes. dot xlsx. Okay, so before we actually run this, I would like to show how my Excel file actually looks. So this is a typical data file that you can see here. And so these are the different column names, and this is an index which has been assigned directly by Excel. So now let us see how this Excel file gets opened in Jupyter Notebook. And as you can see, I've missed something here. And as you can see, it reads exactly how it is C. But the only difference is that here the index actually starts from 0. Now, as you can see here, this consists of 542 rows and 51 columns, but the program does not actually display all of them because of the space constraint and also accessibility. So now what we can do is that if you want to see just first few rows, you just have to type df.add and it's going to show the first 5 rows. Or if you're particular about the number of rows that you want to see, then you just have to type the number of rows that you would like to see within the braces. In the same way, if you can also see the last few columns or last few rows of the data frame by using the command df.take. Okay, and again here, if you want to just see the last 4 rows, just type the number of rows that you would like to view and you can see that. Okay, now apart from that, there are a lot of other interesting things that you can actually do, and I will call it as df.columns. And if I run, it is going to show me the names of the columns that I have. So because we had told that it has 51 columns, so automatically all the each column will have its own name. So here it is showing me the names of all the 51 columns. And why this command is particularly helpful is because if at all if you want to call a particular column and you're not sure about the name of the column, because as you can see here, not all the columns are visible. So in such cases, displaying this columns and fetching that particular column which you would like to see is very easy. So here, let us say I will go with site geology. It's very simple. You just have to type in df of site geology and click run. You can in fact see that particular data series. Okay. So in the same way, just like how we played with a simple data frame, I can use the command ilocate and see the first row of the entire Excel file. Okay, so this is how we can use ilocate command, which comes very handy whenever you're dealing with large amount of data sets. Now, like we saw here, as soon as you import an Excel file into the Jupyter Notebook, the Jupyter Notebook assigns, or the Pandas assigns, its own index value. But if you want to give a separate index value, which is also the one of the columns in your Excel file. So because in this case, I would like to make the record sequence number as the index, because this is basically the index that I would like to use. So I do not want the default index which has been given by Pandas. So automatically I can use the command which is called as df.set index. So basically I'm trying to set the index to something that I'm more comfortable with. Record sequence number. In case if it's a very long name and you're not sure about the syntax, it's very easy to just copy and paste it as it is. So now you can see that the new data frame has a new index which happens to be one of the columns of the file which was loaded initially. So now after having done that, what we can do is that let me say that I want to read a particular column. So I will again go back here. I will take let us say this R rupture, which is basically a distance, and so I am going to load R rupture. So this is particularly a column in the data frame or Panda series, if you would like to call it that way. So it says the length of this Panda series is 542. That means it has 542 rows. Now, after having done that, if I would like to access only the first few rows of it, let us say, since the numbering begins from 0, I'm going to say I would like to view the first 20 rows. So you can automatically see the first 20 rows. In the same way, there are other ways as to how you can also see this. That is df.ilocate. I'm going to mention the column name as I'll go with source. In a column source, I would like to view some intermediate rows, say 4 to 25. Sorry, I have to use this first. So as you can see here, it says 4 to 25. Or to just make things interesting, let me take 50 to 75, and okay, there is no change apparently, but in case if there was any change, you can see here. So when you use the command allocate, the next succeeding command should be the row number itself. That is, in this case, it's an index, and then followed by the column from which you would like to access the data. So in the same way, you can access the entire data frame as well, not just any particular column, by just giving it as from 2 to 10. And you can see the entire data frame between the rows 2 and 10. And another interesting thing about data frames is that we can also load the data from an external URL. So for that, we have a command called as pd.read_csv, and I will take this as the link that I would like the system to read actually. So this is basically the web file I want the command to actually read, and as you can see, it is read. So this was a list of country and the region which it actually belongs to, and as you can see, it has been very effective in reading it. So this is also one of the most important things, and also the reason why Pandas is favored over other libraries, because it has wide applications and you can make use of variety of data types, and manipulation is very easy within the program. So just like how Pandas can load an external file, it can also export the existing file to a different location. For that, we can use a command called as df to csv or to xls, depending upon the data format of the output file that we need. Okay, so now I'm going to give it as ff. So in case if you want it to be saved in a different location, you just have to click or add R here and mention the name of the location in which you would like to see this being saved. Okay, so in this case, I will just go with my previous location which I had loaded originally, and I will take it directly from here. So as you can see, this is going to be, let me just delete this, and I will make this as ff.csv, and there is a braces which is missing, and run. So basically now it has been saved, and we can go and check, and the file has been saved. Okay, so we have come to the end of our tutorial on Pandas with this. So, and I'll see you in the next tutorial.